We are in 6B, subtracting rational expressions. This is very much like adding rational expressions, except for that pesky subtraction sign in the middle. And it opens up some interesting problems. Whenever we see that, we always want to immediately throw that into a plus sign and then distribute out that negative. And the temptation is to just go like that and throw that negative on the first term we see. However, what's really happening here is that negative in the middle is being distributed to the entirety of the second fraction. And when you distribute to the entire fraction, we're actually only going to put it on the top. Because if you took a fraction, let's say you had 1/2, and you distributed a negative sign to the top and the bottom, you would end up with something like -1 over -2, which reduces to +1/2. When you put negatives on top and bottom, you end up creating just a positive number. So we're only going to put the negative and distribute it to the entire top. Meaning we're going to have -m minus n, or -1m minus 1n. And then we can cross out our original. Over here, we have 1m minus 1n. And on the bottom here, you can see that we have the same denominator that we're working with. So in any addition problem or subtraction problem, we care about common denominators. So we turn this into an addition problem, so we should be able to do it just like we did before. Since our denominators are in common already, we can jump straight to cleaning things up and getting our answer. So I have a 1m and a -1m, which cancel each other out to 0. I have a -1n minus 1n, so -2n, that I end up with right here. Now in my finalized fraction, you can see that I have one group on top, one group on bottom. No addition or subtraction going on, so there's no need to factor anything. And when I look to see if I can reduce it, I actually see that I have an n to the 1 on top and on bottom. Those do divide out to 1, so they do cancel each other, leaving you with a final answer of -2 over 12m squared. Actually, look at that. We have numbers that cancel as well. We have a 2 and a 12. So we can reduce that to 6, reduce that to 1, and I guess I should keep that negative there so I don't lose it. So now we actually have -1 over 6m squared. So always check that everything is fully reduced before you call one of these problems done. Let's go on to one more example where we have to get a common denominator, and we can do that with number 27. We see that we have a subtraction problem. We want to turn it into an addition problem, so we distribute our negative to everything on top. Now you'll notice that 2b does not have any addition or subtraction inside. It is just a single term, a single multiplication group, meaning that I do not distribute the negative to the 2 and to the b. I do not do that. I only need to distribute that out front, so I'll put the negative on the 2. So I have -2b. Then I need to get my common denominator. And when I look at these, 2b plus 3 does not reduce or factor out. b plus 2 does not factor out. So I just need to keep these as entire groups together. In order to get something in common, I'm going to multiply the other side by the opposite fraction. So this denominator here, the 2b plus 3, is going to get multiplied over here on top and bottom. Put that up here, 2b plus 3. And then I have the b plus 2 that I need to multiply by top and bottom. And now my fractions are going to both have a b plus 2 term and both have a 2b plus 3 term. So they are going to have common denominators. And I can leave that written just as I have it here, b plus 2 and 2b plus 3. I need to clean up my numerator, so I need to distribute this multiplication problem that I did in order to get that. I take that 2 and I distribute it to the b to get 2b, and distribute it to the 2 to get plus 4. Plus sign in the middle, so I'll throw that right up there. Distribute by -2b times 2b, and that's going to be -4b b squared. My negative 2b times 3 is going to be negative 6b. And now I can combine all of this top together into one condensed group. This is my only b squared term, so I'm going to get negative 4b squared. And then my b's, I have a 2b and a negative 6b, so those combine to negative 4b. And then I have a 4. So plus 4 all over, and then on the bottom I have b plus 2, parentheses, 2b plus 3. It may kill you to see all those 4's right here and say, I know I can factor out a 4 from the top. And that's true, you can. And if you want to, feel free to do so. However, if you look at the bottom, since nothing cancels or factors out of that, you're not going to be able to reduce it, so it won't really end up helping you at all. The only thing that you could check for would be to see if you could factor the top, now that it's all cleaned up, if you could factor that and cancel. To check that, you would factor out the negative 4 out front, leaving you with b squared plus b plus, or minus 1, because you took out a negative 4, so 4 divided by negative 4 is minus 1. And then from here you're looking for two numbers that multiply to negative 1 and add to 1. So two numbers that multiply to negative 1 and add to 1. There are no numbers that do that, because 1 and negative 1 is the only way to multiply to negative 1. So this does not factor, so you could leave it just like this here and leave this as your final answer, and that would be acceptable. Or you could replace that numerator with the one I factored above it in process to see if things would reduce, but in this case they do not. So again, with all these subtraction problems, you just want to immediately turn it to an addition problem and then take your time working through to get a common denominator and clean it up. Good luck!